In this video, we will be discussing two types of special right triangles. Up until this point, we've always known at least two sides of a right triangle, and then we've either used the Pythagorean theorem or a triple to find the third side. Now, with these special right triangles, you only need to know one of the sides in order to find the other two. So that's why we're calling them special right triangles. You will need to memorize both of these special right triangles because you will see them used over and over again throughout the remaining chapters this school year. So the first type of special right triangle that we're going to talk about is called a 45-45-90 right triangle. Now it's named this because those are the measures of its angles. So we have a 90-degree angle and then we have two 45-degree angles. So notice that this is an isosceles right triangle. So we know that since those two angles are congruent, the sides are also going to be congruent. So let's just say that one of our sides is equal to x. Then we know the other side across from the 45 would also have to be x, since those sides are going to be congruent. And then I want to know, what is the hypotenuse of this 45-45-90 right triangle equal to in terms of x? So normally what we would do is we would use then the Pythagorean theorem to figure that out. So let's do that now. So we know that a squared plus b squared is equal to c squared. And now if I combine my like terms, I get 2x squared equals c squared. Keep in mind we're trying to solve for c, so we would have to take the square root of this side. The square root of x squared is just going to be 1x, and then we can't simplify the square root of 2, so we're going to leave that inside of the square root. So that's what our hypotenuse is going to be equal to in a 45-45-90. It's equal to x times the square root of 2. So depending on what information you're given, you should be able to determine the other two remaining sides based on whatever is given. So make sure, it's really important that you take time to memorize this part here. You need to know that the two sides across from the 45s are equal to x, and then the side that's across from the 90-degree angle is equal to x times the square root of 2. Okay, so now to kind of switch gears, we're going to talk about the second type of special right triangle, which is called a 30-60-90 right triangle. Now, this whole triangle comes from the idea of splitting an equilateral triangle in half. We know in an equilateral triangle that all of the angles are equal to 60 degrees. So if we were to split this equilateral triangle in half, if we were to draw that altitude, then we know those two angles at the top would then be equal to 30, and so that's where that 30-60-90 right triangle comes from. Now I'm just going to draw one of those 30-60-90s off to the side here because this is really what you're going to have to memorize. So we'll call that 60, 30. Now the side across from the 30-degree angle is going to be your x in the 30-60-90. So that side that's across from the 30 is equal to x. And I'm going to write it out here because I know this is also another way that some people memorize it. So if we just write x underneath the 30. Then, if we think about that, if we look at the original diagram, if this is x, then this would also be x. So the side across from the 60 would be those two pieces added together, which is equal to 2x. So all of these sides of our equilateral triangle would be equal to 2x. Now notice that this is the side across from the 90. So the side across from the 90 is just 2 times whatever's across from the 30. So we'll think of that as 2x. Now we want to figure out what is the side across from the 60 in terms of x. So again, since we know two of the sides, let's use the Pythagorean theorem to figure that out. A squared plus b squared equals c squared. So if I kind of clean this up a little bit, I have x squared plus b squared equals, if I square 2x, I get 4x squared. subtract the 1x squared, and I get b squared equals 3x squared. Now keep in mind we're solving for b, so we're going to take the square root of 3x squared. I know the square root of x squared is just 1x. I can't simplify the square root of 3, so I'm going to leave that alone. So the side across from the 60 is equal to x times the square root of 3. So you can either memorize the diagram, or if you prefer to memorize this, if that's easier for you, either one. But you are going to need to know what goes across from each of the angles in a 30, 60, 90 right triangle. Okay, so now that we are familiar with the two types of special right triangles, let's see how we can apply it to the given examples on the next page.